all. This is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over 3, 2, 1, let's go. It says factor 10x squared plus 5x minus 15. Whenever it says factor, the first thing we have to look for is a GCF, and I see a GCF here. We can divide all of these terms by 5. So right away, I'm going to put 5 times in my answer. My answer is going to be 5 times something. I always do that immediately because sometimes if I wait to do that to the end, I end up forgetting about my GCF. So as soon as there's a GCF, I just write it on my answer line. All right, so let's get back to what we're looking at. So it's 5 times, let's see, that's 2x squared plus x minus 3. All right. Now we can just sort of focus on this trinomial. So I'm going to sort of ignore the 5 and just rewrite it as 2x squared plus x minus 3. Because I already put the 5 there in my answer, so now I can sort of forget about the 5 because I know it will be there at the end. So now we just have to factor 2x squared plus x minus 3. Well, it's a trinomial, so it's either simple trinomial factoring or the stupid sentence. And since there's a lead coefficient that's not 1, we need the stupid sentence here. We need to use most frogs don't say much. This is the crazy method we covered in a previous video. So if this looks new to you, you might want to go back and watch that video on the stupid sentence. Let's make that look more like an M. There we go. All right, so first we multiply. So 2 times 3 gives us a trinomial of x squared plus x minus 6. Now we can factor it using simple trinomial factoring because we rewrote it with a lead coefficient of 1. Get that circle out of there. Why is this not working? There we go. Oh, that's why. So we're going to get rid of the, so we got rid of the coefficient of 2, or 2, we rewrote it with the coefficient of 1. Now we're going to factor. Okay. Smartboard threw me off there for a second, but where were we? So it's x is in front, and two numbers that multiply to get to negative 6 and combine to get to a positive 1. That's going to be a positive 3 and a negative 2. It doesn't matter what order you write them in. You can put x minus 2 times x plus 3. Just make sure the 2 gets the negative and the 3 gets the positive. Now, we divide. So we divide both of our numbers by the lead coefficient we multiplied, which was 2. We bring that back into the problem. Simplify. X plus 3 over 2 can't simplify that fraction. And x minus 2 divided by 2 is just 1. Then we move any denominators in front, so it becomes 2x plus 3. No denominator to move here. I mean, technically there's a 1, like it's a 1 over 1, but moving that 1 in front just keeps it as 1x minus 1. So usually I just say there's nothing to move there and write it as x minus 1, or keep it the same, I should say. All right, now we just drag that up for our answer. So it's 2x plus 3 times, what was it, x minus 1? I already forget, x minus 1, yes. And that's our final answer for this problem. You got to remember you factor out a GCF before you use the stupid sentence. If you just go straight to using the stupid sentence, not only does it give you like much bigger numbers, 10 times 15 would be a 150, but you're actually not going to get that 5 as part of your answer. You're just going to get 2x plus 3 times x minus 1. And 2x plus 3 times x minus 1 does not equal this trinomial. Right, so remember, the stupid sentence is going to give you the wrong answer if you forget to look for a GCF. So that's something you got to remember to do. Okay, take a look at our objective. Today we're doing chapter 4, section 4, and after today we should be able to factor polynomials. Factor polynomials. So we're not just going to be looking at quadratics today. We're going to be looking at some trinomials that have powers bigger than 2 or that look a little bit different. So that's why it's just polynomials today instead of quadratics. So let's take a look at example 1. We got to factor the polynomial negative x to the 4th plus 11x squared minus 10. Well, the first thing I'm going to do, I'm going to write that right here. So it's negative x to the 4th plus 11x squared minus 10 equals. Let me see. The first thing we should look for is a GCF. And initially it doesn't look like there's a GCF, but I don't like that negative in front. Anytime I'm factoring, I don't like a lead coefficient that's negative. So I'm going to divide everything by a GCF of negative 1, just to make it look a little bit nicer. So I know my answer is going to be negative times something. So I'm going to put a negative in front of the parentheses. And let's see what we get here. So that's negative times x to the 4th minus 11x squared plus 10. Okay, so we got rid of the negative. Now, I mean, we know how to factor a trinomial. We're looking for two numbers that multiply to get to 10 and combine to get to a negative 11 because there's a lead coefficient of 1 here, so we don't need to use the stupid sentence. It's just simple trinomial factoring. But now we have an x to the 4th and an x squared. Now don't let that throw you off. As long as the lead power is double the middle power, then we can still use simple trinomial factoring. But instead of an x in front, it's going to be an x squared in front of our two binomials. Because that's going to give us x squared times x squared to get back to x to the fourth. And now we just need our two numbers. So let's see, a positive 10 to get to a negative 11. So that would just be negative 10 and negative 1. Negative 10, negative 1. There you go, we're all done. And remember, if you want to double check yourself, you can just distribute here. So distribute the two binomials, then distribute the negative 1, or in the other order if you want, and just make sure you get back to our original question, the original trinomial, and we will. So the key about this example is don't get thrown off by the powers there. Just make sure that the power in front, this power right here, is always double the power in the middle, and then you can still factor like it's a trinomial. Or like a quadratic trinomial. That would be a better way to say that. All right, example 2. We got to factor the expression 3x plus 1 squared minus 2 times 3x plus 1 minus 24. Ooh, okay, this looks significantly uglier because, I mean, there's just a lot going on here. A lot of students, when they see this problem, their initial reaction is to try and simplify it. So, okay, let's do the 3x plus 1 squared. So if we know the shortcut, that would just be 9x squared. Let's see, then 3x times 1 is 1, so plus 6x, and we double it, plus 1. Then minus, distribute the 2, or the negative 2, so that'd be negative 6x, minus 2, minus 24, and then simplify all that, and then try and factor it. But I think there's an easier way. I think there's a faster way. It's not that you can't do it that way, there's just a faster way to do it. And the key is what we see right there. We see the same exact expression, a 3x plus 1 in the front. I'll say the front term in this front part and the middle part as well. Since we see the same thing, we can use a substitution method to make this a little simpler. So I'm going to say, okay, I'm going to let 3x plus 1 equals some variable. I'm just going to pick one. I'm going to make it y. I'm just going to let 3x plus 1 equal y. Now, some of you might be thinking, well, wait a minute, where did that y come from? It didn't come from anywhere. It came from me. I made it up. Okay? We'll have to do that in math, as long as, well, we'll talk about what we have to do to deal with this at the end later. But right now, all you need to know is, all right, this looks ugly, and since we have the same two things there, I'm going to rewrite it with a new variable, a y. So 3x plus 1 squared, well, I'm saying that 3x plus 1 equals y. I'm setting y to equal that expression. So wherever I see a 3x plus 1, I can write a y. So instead of 3x plus 1 squared, I can write y squared. We're substituting in a y for that binomial of 3x plus 1. Minus, the 2 comes down, I'm just copying the trinomial. Now I see a 3x plus 1, but remember, we're substituting there. Instead of a 3x plus 1, I can write y, and then minus 24. Now, I don't know about you, but this looks a whole lot nicer. This looks a whole lot easier to factor than what we had earlier. Because here we can just use simple trinomial factoring. There's a lead coefficient of 1. We want two numbers that multiply to get to negative 24, add to get to negative 2. So that's going to make the binomial y minus 6 and y plus 4. Let me double check my signs. When you multiply those two together, we get negative 24. Combining, we get negative 2. Okay, very good. So we're done factoring. But this can't be our final answer. Because they gave us an expression with x's in there. We're the ones that sort of invented this new variable of y. We introduced the variable of y to this problem. So we can't give them an answer with y's in it. But now we just substitute again. So, all right, they wanted x's. Well, we know what y equals. We set y to equal 3x plus 1. So now, instead of y minus 6, I put 3x plus 1 minus 6. And instead of y plus 4, it's 3x plus 1 plus 4. We just substitute our 3x plus 1 back into our final answer, and then we simplify it. So we get 3x minus 5 times 3x plus 5. Oh, it's kind of weird. We end up with what looks like sort of a difference of squares factoring problem. But yeah, whatever. Let's not let that throw us off. And there we go. We're done. Oh, let me write this. They didn't give us an answer line, so I'll just put a box around it to show us the final answer. So the key to this problem was recognizing that we had the same expression, and then knowing, oh, okay, We can make this a lot simpler by substituting a variable in there and then substituting the expression in at the very end. It's almost like we're sort of leaving the simplifying to the end after we factored. I think it makes it a lot quicker. And the idea of using something like this to substitute in is a really useful skill in algebra, and especially when you're doing algebra in like pre-calc or calculus. The further and further you go in your mathematical career, the more this starts to show up. It's like, all right, this looks ugly. Let's substitute a variable to make this a lot simpler. Let's take a look at another example. So we got to factor the expression 5x plus 7 squared plus 13 times 5x plus 7 plus 12. Again, this looks ugly. I mean, we could simplify it. We could square the binomial, then distribute the 13, then simplify, then try to factor, but we've got the same binomial here. So let's use a substitution method. Let's just say, okay, let's let that binomial 5x plus 7, let's let that equal n this time. It doesn't matter which variable you pick, so I'm going to pick a different one because I don't want you to think it always has to be y. Let's use n this time. So 5x plus 7 squared, that just becomes n squared, plus 13 times 5x plus 7, that's just 13 times n. And the plus 12 just comes down. Now we've got a simple trinomial factoring problem. This is going to be a lot easier to deal with. Two numbers that multiply to get to 12 and combine to get to a plus 13. That's just going to be n plus 12 times n plus 1. But remember, they gave us problems, they gave us an expression, I should say, with an x in it. So we have to substitute the 5x plus 7 back in because we said it equals n. I know I'm sort of emphasizing that point, maybe a little bit too much, but that's the key to this whole method. So n plus 12, we can rewrite that as 5x plus 7 plus 12 times n plus 1 is 5x plus 7 plus 1. And we just simplify. We get a little bit more space. So we get 5x plus 19 times 5x plus 8. And we are finished. Just one more to go. I want you to try this one on your own. So pause the video right here. Give this problem a shot. Come back when you think you have an answer. 3, 2, 1, let's go. Right away, we see the 4x minus 1s, so we can substitute. I'm going to use a w this time, so 4x minus 1, I'm going to let that equal the variable w. Then I can rewrite this expression as the trinomial w squared minus w minus 90. Okay, now we're looking for two numbers that multiply to give us negative 90 and combine to give us a negative 1. Again, since this is a leading coefficient of 1, this is just simple trinomial factor. So we get w, let me think, that's going to be minus 10 and plus 9. If I'm doing that correctly in my head, let me double check myself. When we multiply those two, we get negative 90. When we combine, we get negative 1. Okay, so far so good. Now we just have to substitute our 4x minus 1 back in to get our final answer. So it's 4x minus 1 minus 10 and 4x minus 1 plus 9. And then we get 4x minus 11, just simplifying here, times 4x plus 8, and we are finished. That's our final answer. Now it's time for our homework assignment. It's going to be in page 222 of your textbooks, numbers 85 through 88. They're very similar to the problems we did in this video. Hopefully this all made sense. If you have questions, as always, reach out to me and let me know. Enjoy the rest of your day.